See, let's say I have a scenario like this. I have two switches, switch 1 and switch 2. I have some user here, PC1 and let's say PC2. We have only two user. Here also we have two user, PC1, PC3 and PC4. Okay. Switch 1, switch 2, PC1, PC2, PC3 and PC4. Let's say this PC is in VLAN 10. This PC is in VLAN 10. This PC is in VLAN 20. VLAN 20. Again this PC is in VLAN 10. VLAN 10 and this PC is in VLAN 20. Now guys, can PC1 communicate with PC2 by default? No.
No.
Right, because both belongs to different VLAN. Can PC1 communicate with PC3? Yes, it should communicate because both belongs to same VLAN. But here I need one connection between switch 1 and switch 2. Correct? Correct. Now tell me, can PC1 communicate with PC3? By default, this interface is member of which VLAN? VLAN 1. This interface is also member of which VLAN? VLAN 1. Can PC1 communicate with PC3 in this scenario? Can PC1 communicate with PC3? Let's say PC1 IP address is 10.1 and PC3 IP address is 10.2. PC2 IP address is 20.1. PC4 IP address is 20.2. Can 10.1 ping 10.2? If no,
I think no.
if no, then tell me why. Where my traffic will drop? On which device? Let's say this machine MAC address is A, this machine MAC address is B, this machine MAC address is C, and this machine MAC address is D.
I think switch 1 don't have the MAC table of switch 2.
Okay, so if switch 1 should perform a non-unicast flooding, so it will forward one copy to switch number 2. Then maybe switch 2 will drop the packet. See what will happen here. When 10.1 will ping to 10.2, source MAC will be A and destination MAC will be B. Correct? Now PC will forward this frame to switch. Switch 1 will receive it on this interface, which is member of which VLAN? VLAN 10. So switch will look up MAC address table for VLAN 10 only, right? And is there any other interface available which is member of VLAN 10? Which is member of VLAN 10? No. Is there any trunk
No.
link available? No. So switch 1 will simply drop the packet, yes or no? It will not perform a non-unicast flooding here. Correct? But if I will put this interface in VLAN 10, now what will happen? Switch will again check their MAC address table. Right now this interface is in VLAN 10. Again switch will check their MAC address table. Let's say in the MAC address table there is no any entry available for destination MAC. So this time switch will perform a non-unicast flooding, right? That means it will forward one copy from all the interface which are member of VLAN 10. Means switch will forward one copy from this interface, yes or no? Means switch will forward one copy from this interface because this interface is member of VLAN 10. Correct? Correct, guys?
Yes.
Yes. Okay, when switch 2 will receive the frame, it will receive on this interface, and this interface is member of which VLAN? VLAN 1. So switch 2 will think what? This is packet of VLAN 1, not VLAN 10. Yes or no? According to switch, this is frame of VLAN 1, not VLAN 10, because my receiving interface is member of VLAN 1. So a switch 2 will receive frame on the interface which is member of VLAN 1. That means switch 2 will think that this is a packet of VLAN 1. And is there any interface available in VLAN 1? No. So switch 2 will discard the packet this time. Correct? If I will put this interface also in VLAN 10, now when switch 2 will receive the frame, it will think that this is a frame of VLAN 10. So this time switch 2 will forward one copy from this interface, right? And now PC1 can ping to PC3. Now PC1 can ping to PC3, because in the same way when PC3 will generate reply, source will be B, destination will be A. It will forward to switch. Switch will, check receiving interface VLAN is 10. It will look up their MAC address table, right, for VLAN 10. And definitely switch 2 will have entry for destination MAC address on this interface, right? Because when switch 2 will receive frame on this interface, it will learn source MAC address, it will learn a MAC address on this interface, so it will forward the frame from this interface, right? And switch 1 will receive the frame again. Switch 1 is receiving it on this interface which is member of VLAN 10, so it will forward the packet from this interface, right? And this is how PC1 can communicate with PC3. Correct? Now PC2 can ping PC4. Means VLAN 20 user can communicate with each other. No, because if PC2 will ping to PC4, source MAC C, destination MAC D, right? It will forward the frame to switch. Now switch will receive it in this interface. This interface is member of VLAN 20. It will look up their MAC address table. If entry is available, if entry is not available, right, it will perform unknown unicast forwarding, but there is no any interface available in VLAN 20. So it will discard the packet. Again, if I want to make communication possible between PC2 to PC4, right, I need to connect one more cable here, right? And this interface should be in which VLAN? In VLAN 20. And this interface should be again in which VLAN? VLAN 20. Right? Now VLAN 20 user can also communicate. So like this, if we have user in 10 VLANs on switch number 1, we have 10 VLAN on switch 1 and we have 10 VLANs on switch number 2. So how many link I need to connect between switch 1 and switch 2?
10.
10, right? So this is not the actual method which we will use, in this scenario. We will not connect 10 number of cable, because let's say I have purchased, I have purchased this switch to connect users. Let's say on this switch we have 48 ports. We have 48 ports, right? On this switch also we have 48 ports. And we have 10 number of VLAN on each switch. So if I will connect 10 number of cable between switches, then how many ports are left there? 38. Means I can connect only 38 computers. If we have 20 number of VLAN, I need to connect 20 number of cable. That means only 28 ports are free on this switch to connect computers and user. Then what is solution? Solution is trunk link. Trunk link. So a single link can carry traffic of multiple VLAN, right? There are two, as I told you in last class also, there are two types of switch port. First one is access port and second one is trunk port. Trunk port. Access port is the port which is member of single VLAN, and trunk port is the port which is member of all VLAN, or you can say multiple VLAN. So let's say I have configured this link as a trunk now. That means this interface is member of VLAN 10 also, and this interface is member of VLAN 20 also. This interface is member of VLAN 1 also, VLAN 30 also, 50 also, 100 also, right? By default, now this interface is member of all VLAN. Now question is, if this time 10.1 want to communicate with 10.2, again source MAC A, destination MAC B. This PC will forward frame to switch. Switch will receive it on this interface. This interface is member of VLAN 10. Again switch is going to check their MAC address table. If entry is available in MAC address table, then definitely destination MAC will be learned on this interface, right? Because switch 1 will learn MAC address of PC3 on this interface only. Let's say this is 0/1 on 0/1 interface. If entry is not there, then switch need to forward one copy from all the interface which are member of VLAN 10, and trunk link is member of VLAN 10. So it will forward one copy from this interface, right? Again, this interface is also trunk. So when switch 2 will receive the frame on this interface, how switch 2 will came to know that this is a frame of VLAN 10? Because this time it is receiving frame on which interface? On trunk interface. How switch 2 will came to know that this is frame of VLAN 10 or this is packet of VLAN 10? Right. Okay. Whenever switch will receive any frame on trunk link, switch cannot identify this traffic belongs to which VLAN. So that's why whenever switch will forward frame on trunk link, it will perform tagging. It will perform what? Tagging. So here switch 1 is forwarding frame from trunk link. So switch 1 will add one tag with packet with frame in the frame source MAC is A, destination MAC is B. It will add one tag number here. Tag number is 10. So now if when switch 2 will receive this frame, first switch 2 will check this tag number. So tag value is 10. That means this is frame of VLAN 10. Switch 2 will simply remove this tag and it will check what is destination. Inside the tag VLAN is 10. That means I am receiving frame of VLAN 10. Let me check destination. Destination is B. It will look up for their MAC address table. For which VLAN? For VLAN 10. And then switch 2 will forward frame to PC number 3. Okay. Okay. Let me ask you one question here. If your VLAN concept is clear, then tell me, let's say I have a scenario like this. Switch 1, switch 2. Here I have one user whose IP address is 10.1.1.1 and this PC is in VLAN 10. Here I have one user whose IP address is, let's say, 10.1.1.2 and this user is in VLAN 20. VLAN 20, and I have one link between switch 1 and switch 2. Now I don't want to configure this link as a trunk link. Okay, or question can be, this is interview question. Okay, question is, this link, you are not allowed to configure this link as trunk link. Between switch 1 and switch 2 you don't have trunk link and you are not allowed to configure this link as trunk. Then how you can make communication possible between 10.1.1 and 10.1.1.2? How 10.1.1.1 can communicate with 10.2 without configuring trunk link in this scenario? What I can do?
Configure VLAN 10 on the output interface of switch 1 that is connected to switch 2,
So this interface should be in VLAN 10. Yes,
and that interface should be VLAN 20, that switch interface 2
correct.
interface.
Now what will happen? When this machine will forward packet to this machine, right? It will forward to switch will receive it on this interface is member of VLAN 10. It will forward frame from the port which is member of same VLAN. So this interface is member of same VLAN, so it will forward the frame from this interface without tagging, because this link is not trunk link. So when switch 2 will receive the frame, switch 2 will receive it on this interface, and this interface is member of which VLAN? VLAN 20. So switch 2 will think this is a frame of VLAN 20, right? So it will forward, switch 2 will forward frame to this PC. And again, when this PC will generate reply, switch 2 will receive reply. It will receive reply on this interface. This interface is member of VLAN 20. So it will forward one copy from this interface, because this interface is also member of VLAN 20. Again, when switch 1 will receive the frame on this interface, this interface is member of VLAN 10. Switch 1 will think this is a frame of VLAN 10. It will forward a frame to this PC. And this is how 10.1 can ping to 10.2 without configuring trunking here, right? Okay, let's say I have one another scenario. Is this scenario clear to everyone?
Yes, yes.
Okay.
Yes.
Now let's say this time I have one switch. Here I have one PC, and this PC is in VLAN 10, and this PC is in VLAN 20. Here IP address is 10.1, IP address of this machine is 10.2. I want to, make communication between 10.1 and 10.2. How I can, make communication possible between these two devices here in this scenario? Any solution?
We need router here.
No, router, we don't have router here. So guys, here also, this is not like, practical example. Practically, definitely we will not use this type of scenario. You will never see this type of scenario in real time. But to clear your concept, interviewer can ask you, or you to check your concept, interviewer can ask you this question also. Here also we can achieve communication between 10.1 and 10.2. How? Here I need to use two unused port. Let's say here we have two port, 0/3 and 0/4. If I will connect these two port together with one single cable, and I will make member of this port to VLAN 10 and this port to member of VLAN 20. Now these two devices can communicate with each other or not?
Do we get a loop here if you connect two ports like this?
No. Why we will get? Both are in different VLAN. Na? So what will happen here in this scenario? See, again, when 10.1 want to communicate with 10.2, 10.1 will generate packet, it will forward to switch will receive it on this interface. This interface is member of VLAN 10, so it will forward one copy from the other interface which is member of same VLAN 10. So this interface is member of VLAN 10, it will forward one copy from this interface. Same switch will receive frame on other port on 0/port, which is member of which VLAN 20. So now again this switch is going to forward frame to frame from the ports which is member of which VLAN 20. So this time switch will forward. Yes.
Praful, if it is the same switch, okay, if you are going to configure the two VLANs, how the VLAN 10 information will go to VLAN 20? If even if you are going to connect the cable from 3 to 4 interfaces. Actually, we have grouped the interfaces 1 and 3 for VLAN 10 and 2 and 4 for VLAN 20, right?
Yes.
So other VLAN information definitely it will not come to the other VLANs, right?
Other VLAN means?
Like VLAN 10 information will not come to VLAN 20, right? Even if you are going to connect the cable, because we have segregated the port for VLAN 10 and VLAN 20. For example, as you said, interface 1 and 3 used for VLAN 10 and 2 and 4 used for VLAN 20, right?
Right.
Both are different VLANs. So VLAN information definitely will not come to that. VLAN 10 information will not come to that VLAN 20, right?
VLAN 10 information not come to VLAN 20.
Okay.
What you are saying? VLAN 10 information not come to VLAN 20 means?
Like we are segregated the ports 1 and 3 we have assigned for VLAN 10 and 2 and 4 we have assigned for VLAN 20.
Correct.
So both are different VLAN. Then even if you are going to connect the cable from 3 and 4, then how the reachability will come? That's my question.
Reachability will come. See, when switch will receive frame on this port. This port is member of VLAN 10, so it will forward one copy from this port. And same switch will receive that frame on this port on 0/4, which is member of VLAN 20. So this time again switch is going to forward frame from port which is member of VLAN 20. So it will forward from 0/2. Again, when this PC will generate reply, switch will receive reply on this port which is member of VLAN 20. So it will forward one copy from this port. Again, same switch will receive that frame on this port, which is member of VLAN 10. So same switch will forward that frame from this port.
Okay. If you are going to configure multiple VLANs in a switch, even though the VLAN information will pass all the interfaces, right?
Yes.
Okay.
If a switch is receiving a frame, right, and which on the interface which is member of VLAN 10, so it will forward that frame from all their interface which is member of VLAN 10, which are member of VLAN 10, if MAC address is not available. And definitely this switch will learn MAC address of 10.2 on this port and MAC address of this PC on this port. Actually, this switch will learn MAC address of this PC on two port, one on this port and one on this port, 0/4 and 0/1. Switch will learn MAC address of 10.2 on two port, 0/2 and 0/3.
Okay.
Cable with two port. And I can perform this lab as well, right? But this lab is not possible in simulation software like in Packet Tracer or in GNS3 or in EVNG. But we can perform this lab in rack, on rack.
If we connect the ports that are in same VLAN 10, VLAN 10, two ports. If two ports are in VLAN 10, can we connect through a wire like that? Does it create any error or?
No, it will not create any error. It will work
For
fine.
your diagram is okay. If both are 10, VLAN 10.
If both are, then why you need to connect cable? Then definitely both will communicate with each other, na? If both are in VLAN 10, then we don't need to connect cable, na?
If we connect by mistake, will it cause loop or it will be okay?
Okay, if this interface is also in VLAN 10, so see, if it will receive frame, it will forward one copy from this interface, so it will receive it on this interface, which is, no, again, it will not form loop.
Okay.
But that
Suppose
from
in general switches,
Hmm.
if you connect this like one cable, same cable connected to some port, port 1 and port 3 or something port 2, in generally switches it is creating a looping, na?
How, brother?
Without VLAN, if you connected the switch, some one cable in 0/1, and second end we connected the 0/3. It is creating some looping, no?
If you will connect cable like this interface is
Mm.
VLAN 1, or this interface is also in VLAN 1. Here loop can form. How loop will form here? See, if switch will receive a frame, right, where let's say destination is A. Destination MAC address is A, and inside the MAC address table, if entry is not available in MAC address table, then loop will form. What will happen? Because switch will forward one copy from this interface, a non-unicast flooding, and again switch will receive that on this interface. After that, same switch will forward that from this interface. So if MAC address table is not updated or destination MAC is not available in MAC address table, then loop can form here. In that scenario only loop will form. Otherwise, let's say here we have one port and we have one user whose destination MAC address is A. This is port 0/1 in VLAN 1. So if switch is receiving frame where destination is A and receiving interface is in VLAN 1, right? So switch will check their MAC address table. In their MAC address table, exit interface is there, right? That this is the exit interface for destination MAC for A. So it will forward one copy from this interface only. It will not forward copy from this interface and this interface. So if MAC address table means destination MAC is not available in MAC address table, then definitely loop will form. But why you will connect one cable like this? Both are in same VLAN. You will not connect two ports together. What you are doing actually, you are reducing number of ports on switch. And definitely loop will also form here. Loop can form in this topology. Right? But in this topology, loop will not form. In this scenario, loop will not form. Done. So if you have understood these three scenario, that means your VLAN concept is clear. Any question? No?
Yeah, how it will add the tagging, VLAN
For
tagging we
tagging,
have.
we have a protocol,
Okay.
right? So let's say we have again two switch 1, switch 2. We have one link, and this link is trunk link. Here I have one user, two users here and two users here. VLAN 10, VLAN 20, VLAN 10, VLAN 20, right? So to configure trunk, guys, before configuring trunk, you have to define encapsulation protocol. Trunking encapsulation protocol means which protocol is going to add tag number, which protocol is going to perform tagging. And we have two protocol for tagging. One is ISL and another one is .1q. .1q. Nowadays we are not using ISL. ISL is Cisco proprietary protocol, and nowadays Cisco is also not using ISL, right? Cisco is also using .1q because we have some advantage uh, of using .1q over ISL. So earlier we were using ISL protocol, but nowadays we are using .1q protocol, right? These two protocols are responsible for tagging, right? It will perform tagging. So if I want to configure this interface as trunk, so before configuring this interface as trunk, I have to define encapsulation protocol, that which encapsulation protocol is going to perform tagging. Okay, so let's say here encapsulation protocol is .1q. Here also encapsulation protocol is .1q, and .1q and ISL both are not compatible with each other. So if you are configuring .1q, both side you have to configure same encapsulation protocol. If you are using ISL, both side you have to configure ISL. Okay, command to define encapsulation protocol is on interface, let's say f1/0/1. Here you will run command switch port trunk encapsulation and .1q or ISL, right? Or if I will configure .1q here, right, automatically switch 2 can negotiate encapsulation protocol. Automatically switch 2 will also configure .1q encapsulation protocol on their interface. For that, negotiation should be on. For that, negotiation should be on. So actually on interface we have two command, right? No negotiation, switch port no negotiation, switch port no negotiation, and switch port negotiation. By default, switch port negotiation command is running. Switch port negotiation is hidden command on all interfaces. Okay, and after defining encapsulation protocol, we can run command switch port mode trunk. Switch port mode trunk. So
Can we use access link?
access list,
Link.
access link.
Yeah.
By default, all ports are access port. If you will configure this port as access port, that means this port will carry traffic of single VLAN.
Okay.
Okay. Now guys, huh? Yes.
Access port of VLAN 1 or by default all
By
ports are
default, access port for VLAN 1.
okay.
Now to configure trunk, again we have two methods, static and dynamic. Manually I can run switch port mode trunk command, or I can configure a dynamic protocol, that is DTP. And if you want to see the difference between ISL and .1q, let me show you. Not visible. Okay, both are treated, both protocol maintain VLAN information as the tagging.q. One difference is ISL protocol add 20 bytes of extra information, right? Whenever ISL protocol perform tagging, right, it will definitely add one header. So header length of ISL is 20 byte. 20 byte is huge information, right? Means my total length of frame is going to be large, so we need more bandwidth. It will utilize more bandwidth. And .1q uses only 4 bytes extra information, only 4 bytes extra information, right? So this is one difference, and this is the biggest difference between ISL and .1q, and this is the reason why we are not using ISL protocol, because header length of ISL is greater than header length of .1q. So when we will configure .1q and ISL, I will capture the link and then I will show you some differences.
ISL is Cisco proprietary, right?
Yes, ISL, second difference is ISL is Cisco proprietary, .1q is open standard. ISL does not support native VLAN. Means, for native VLAN also ISL perform tagging, and .1q does not perform tagging for native VLAN. Native, concept of, let me discuss concept of native VLAN. Okay. First, let's say guys, I have two switches, switch 1 and switch 2. On both switches we have some VLAN. Let's say 10 number of VLANs are there and 10 number of VLANs are there, right, on switch number 2. Okay, most of the user on switch 1 belongs to VLAN, let's say 5. Most of the user on switch 1 and switch 2 belongs to which VLAN? VLAN 5, right? So as you know, whenever switch will perform tagging, means whenever switch 2 will forward traffic on trunk link, it will add tag, and whenever switch 2 will receive traffic on trunk link, it will remove tag. Or when switch 2 will forward traffic on trunk link, it will add tag, and switch 2 will remove tag. Whenever switches perform tagging, right, adding tagging or remove tagging, that means switches are using their CPU. So to reduce CPU utilization of switches, we come up with concept of native VLAN. Right? So as I told you, most of the user on switch on these switches belongs to VLAN 5. So what I want, for VLAN 5, switch should not perform tagging. Switch should not perform tagging. Means whenever switch 1 need to forward traffic from this trunk link of VLAN 5, it should not add tag number. It should not tag at number, and whenever switch will receive untag frame on trunk link, switch will came to know that this is a traffic of a special VLAN, and that special VLAN is native VLAN. That special VLAN is native VLAN. So I can tell to both switch, for a special VLAN, that is native VLAN, which is my VLAN 5, for this VLAN please do not perform tagging. So by default VLAN 1 is native VLAN. So if switch 1 will forward frame of VLAN 1 from the trunk link, it will not add any tag. It will not add any tag. And whenever switch 2 will receive untag frame on trunk link, it will came to know that this is a frame of VLAN 1. So native VLAN on both switch should be what? Same. So let's say native VLAN on switch number 1 is 5 and native VLAN on switch number 2 is 10. Native VLAN on switch 5 is, switch 1 is 5 and native VLAN on switch 2 is 10. Now see the problem. Switch 1 will not perform tagging for which VLAN? For VLAN 5. Switch 2 will not perform tagging for which VLAN? For VLAN 10. So whenever switch 1 will forward frame of VLAN 5, right, it will forward without tagging. So whenever switch 2 will receive traffic of VLAN 5, it will think that this is traffic of VLAN 10, not VLAN 5. So native VLAN on both switches should be same. If you will configure different native VLAN, you will get one error message as well. You will get one log message that native VLAN mismatch. Native VLAN mismatch. So native VLAN on the trunk link should be same. Why we come up with native VLAN? To reduce CPU utilization of switches. For a special VLAN where we have lots of user or most of the user belongs to a particular VLAN, and for that VLAN I don't want to perform tagging, so I can configure that VLAN as a native VLAN. So native VLAN is a special type of VLAN. For that, switch does not perform tagging on trunk link. Except native VLAN, for all VLAN switches will perform tagging on trunk link. Clear?
In real-time scenario, where will be using this native VLAN?
In same scenario, let's say we have two switches. On switch number 1 and switch number 2, we have, most of the user belongs to VLAN 10, right? Or most of the user belongs to VLAN 1. So I can configure VLAN 1 or VLAN 10 as a native VLAN on these switches, so that these switches should not perform tagging. This is
Yeah,
real
but
time scenario.
actually the thing is, normally if it is a enterprises network, normally we'll be configuring the VLAN, right? We'll be assigning the VLAN numbers. So
Correct.
yeah, so that's what I'm asking. So in
Yeah,
this,
so it depends on your requirement, na brother. Your company will, tell you that which VLAN should be your native VLAN. And logically logically, like which VLAN should be my native VLAN. So where most of the users are present, that VLAN should be native VLAN.
If native VLAN is configured as 5, VLAN 5 is configured as native VLAN, then VLAN 1 will be tagged, right? While sending the frames through the trunk
Yes,
link.
yes, correct, 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 correct.
Okay.
Okay, so if I will talk about ISL protocol, ISL protocol does not support native VLAN. Means if my native VLAN is 1 on switch number 1 also and on switch number 2 also, so if I have configure ISL protocol as a encapsulation protocol, then switch will perform tagging for VLAN 1 also, for native VLAN also. Okay.
What we discussed till now, these are all the port-based VLAN. No?
Port based VLAN means Port based VLAN means we are assigning ports in VLAN.
Yes.
Yes, yes, you can say these are port based VLAN.
That means manually configure the switch port for the member for VLAN, I think.
Correct.
Can we do it for based on the protocol also?
VLAN configuration. Yes, we have VTP protocol for VLAN configuration.
That is protocol based. Okay.
Is there any specific command for native VLAN, or we can directly use for .1q?
Switch port trunk native VLAN. Command is switch port trunk native VLAN, and after that VLAN ID. So let's say 5. So with the help of this command, we can make VLAN 5 as a native VLAN. By default, native VLAN is VLAN 1. By default, VLAN 1 is configured as native VLAN on all switches.
For security purpose, they will change the native VLAN as some other VLAN, like VLAN 5, like that. They'll change. If some
Correct. Otherwise, attack
VLAN,
can be, yeah, someone can
they,
attack in your network with the help of native VLAN.
How it is? Can you please explain?
Don't worry, we have topic. That topic. Let's say here I have one server on switch number 2, right? And this server is, let's say, in VLAN 10, right? And you are attacker. You know my server is in which VLAN? In VLAN 10. So somehow if you will connect your computer here or somewhere, right? And you are attacker, you want to put some virus on this server, right? Just let's say, just I am creating scenario, right? You you can put some virus on server so that my server can crash. Okay. So now see what you will do with the help of some application. With the help of some application, what you can do, you can add tag with your frame, with your actual message. By using some application, attackers can add tag number. Attacker can add tag number. So let's say you have generated one packet and you have add tag number 10, and now this interface is in which VLAN? VLAN 1. You have put your computer in VLAN 1. You will forward your frame to switch. Now this switch will check receiving interface VLAN is VLAN 1. So it will forward one copy from this trunk link without adding tag number. Switch 2 will receive it. Switch 2 will check VLAN tag. Inside the tag number is 10. Switch 2 will think this is a frame of VLAN 10. It will forward to server. It will forward to server. But let's say you have changed the native VLAN. Now native VLAN is 5 on this switch. Now you don't know what is native VLAN, right? You know my server is in VLAN 10. So again you have created one packet. You have add tag number 10. And you will put your interface in VLAN 1. You will forward the frame to switch. Switch 1 will forward it from the trunk link. But this time native VLAN is not VLAN 1, VLAN 5. So it will add what? Tag number 5. And in the packet tag number is 10. But switch 2 will check outer tag number. So tag number is 5, right? It will not forward. This time switch 2 will not forward this frame to server. Yes or no? Because of that we should change native VLAN from 1, because by default native VLAN is VLAN 1. So most of the people know what is native VLAN. So with the help of native VLAN, someone can enter in my network. Because let's say this is in, this switch is in a secure location, but this switch is connected with lots of switches. right? Or lots of networking devices, maybe there's some router, and we have some sites in open location. There also we have some devices, and all devices are connected, right? So here you can connect your computer, right? And you can put some viruses on server with the help of native VLAN. So because of that, we are saying generally we should change native VLAN for security purpose. Got it?
Yes.
Okay. Now to configure trunk manually, you can run command switch port mode trunk, and to configure trunk dynamically, we have a protocol called DTP. DTP stands for dynamic trunking protocol. Okay, in DTP, actually we need to understand modes of DTP. We have two modes. One is dynamic auto, and another one is dynamic desirable. Yesterday we seen by default administrative mode of all interfaces is dynamic auto. By default administrative mode of all interfaces is dynamic auto. What is DTP protocol? DTP protocol is a layer 2 protocol which is used to form trunking between switches dynamically. How you will explain in interview? If interview will ask you what is DTP protocol, DTP is a layer 2 protocol which is used to form trunking between switches dynamically. Very simple. Now let's say here I have two switches, switch 1 or switch 0 and switch 1. So interface fast Ethernet 0/1 and switch port. See the output. Administrative mode is what? This is guys packet tracer, right? On real devices you will see administrative mode will be always dynamic auto. Dynamic auto. So here administrative mode is dynamic desirable, that means so interface trunk link should be trunk. So you can see automatically this link is configured as trunk. This link is configured as trunk. So interface fast Ethernet 0/1 and switch port. Operational mode is trunk. But on real devices, by default, all operational mode of all interfaces is going to be access by default. Access for which VLAN? For VLAN 1. And administrative mode is going to be dynamic auto. Okay. So we have two modes in DTP, dynamic auto and dynamic desirable. Dynamic auto can form trunking, but it will never initiate trunking. It will never initiate trunking. If never switch will give some signal to form trunking, then dynamic auto mode can switch their interfaces to trunk. They can form trunking, but it will never initiate trunking, right? It will never initiate trunking. It can form trunking like this is like here let's say there is one boy, right, and there is one girl, right? This boy want to propose this girl, right? Want to propose this, definitely girl never propose boy. Yes, always boy propose to girls. And this girl will accept the relationship, will accept the proposal, right? So this girl is like dynamic auto, means if someone will send me the proposal, then I will accept it and we will form relationship, right? But I am not going to send proposal to any other boy, to any boy. So dynamic desirable is like boy who always initiate proposal, and dynamic auto is like girl who always accept the proposal, who never initiate proposal. So let's say I have two switch here, switch 1 and switch 2. Here both side, if we have mode what dynamic auto and dynamic auto, will trunking form? No, because both are waiting. If someone will tell me to form trunking, then definitely I will form trunking, but I will not initiate. So if I will configure dynamic auto one side, dynamic desirable one side. So once I will configure this interface as dynamic desirable, this interface is going to initiate trunking, right? And dynamic auto can then switch their interfaces to trunk. They can form trunking with the help of DTP message. With the help of DTP message, this switch can form trunking. So let's say I have again two switch and I want to configure trunking between these two. This is switch 1, this is switch 2. And by default, as I told you, DTP is by default enable on switches, and by default mode is dynamic auto. By default mode is dynamic auto. So let's say I want to form trunking. So if I will configure trunking manually, on both switch I need to run command switch port mode trunk. On both switch I need to run command switch port mode trunk. But with the help of DTP protocol, on single switch, if I will change administrative mode to dynamic desirable, automatically here switch number 2 is going to change their mode, their port role, means operational port. Operational mode will be what? Trunking here. Okay, so like interviewer can ask you question, can dynamic auto and dynamic auto form trunking? So answer is no. Can dynamic auto and dynamic desirable form trunking? So answer is yes. Can dynamic desirable and dynamic desirable form trunking? Answer is yes. Layer 2 forwarding, MAC address table. VLAN, extended VLAN. Here also you can read about extended VLAN and extended VLAN. Then tagging, frame encapsulation. So you can see the difference between ISL and .1Q. ISL is Cisco proprietary, .1Q is open standard, right? ISL perform external tagging, means it will add one extra frame, and .1Q perform internal tagging, right? ISL is going to add 26 bytes extra information, not 20 byte, right? And .1Q is going to add only 4 bytes extra information. By default enable on every switches, but on new switches by default ISL is not enabled, .1Q is enabled, even on Cisco new switches, right? Always support on open vendor devices. And then these are size, what will be the information inside the frame. Then we have concept of native VLAN. Like native VLAN is used to perform untag, to send untagged traffic for that VLAN. This has maximum number of users to reduce CPU utilization. One trunk port can have one native VLAN configured. One trunk link should have same native VLAN, and then inter VLAN routing DTP protocol. Here you have dynamic trunking protocol DTP. Okay, so it is, as I told you, it is, this protocols is like negotiation protocol. If both side mode is dynamic auto, then trunk will not form, because switches are not going to send any message of DTP, right? Dynamic auto mode always wait for negotiation. Between the switches, DTP will help to form trunk automatically. DTP is Cisco proprietary protocol, layer 2 protocol, and negotiation of encapsulation type .1q ISL. DTP sends packet periodically after every 30 seconds, right? Means switches is sending message of DTP periodically after every 30 seconds, right? And this is the multicast address, on which address switches is going to send DTP message. So yesterday I had seen you some static entry inside the MAC address table, and this MAC address was also there. So this MAC address is for DTP protocol, and hold on time of DTP is 300 seconds. Means when switch will send any message of DTP to their neighbor switch will keep that information for 300 seconds. If a switch will not receive any message of DTP from their neighbor till 300 seconds, it is going to again set their mode dynamic auto if it have negotiated trunking. It is used to create trunk port and access port dynamically. By default, DTP is enabled on all switches. In order to run DTP, port should be configured as dynamic access. If port is configured as static access, then DTP will be turned off automatically, right? So interviewer can ask you how to turn off DTP protocol from the switch. So you need to configure port static access. Administrative mode should be what? Static access. Like in this topology, I want to disable DTP protocol. So simply I can go to interface fast ethernet 0/0 and I can say switch port mode access. Switch port mode access. So interface F0/1 switch port. Now you can see administrative mode of this interface is static access. So actually I have disabled DTP protocol on this interface. I have disabled DTP protocol on this interface. And now if you will check trunking, so you can see so interface trunk. Now we don't have any trunk link on this switch. Okay, then modes of DTP dynamic auto, and this mode wait for initiator who from trunk with it, otherwise it will become access. And dynamic desirable is going to initiate the negotiation. It will negotiate to form trunk. So administrative mode can be what? A static access, it can be a static trunk, it can be dynamic auto, or it can be dynamic desirable and down. Operational mode can be trunk, access, or down. Okay, then again we have encapsulation protocol. So this is all about DTP protocol. Tomorrow we will implement it. Any question, guys?